Hey guys, John here. So today I thought I'd give you a little bit of insight into some of the data analysis that I do. Uh, and so let's just dive right in. So this is STATA code. And you can see where am I this Visual Studio is the IDE. Visual Studio is what I'm using. And they do have STATA syntax highlighting as a plugin in the or an extension in the VS Code extensions. So in this other folder, I have the check marks is tortoise git, and you can see here is tortoise git. So I'm using git to source control these text files. And you can see the repository. This is open source. This is on my GitHub. Data science practice is the repository. Subfolder of Stata. And then today we're looking specifically at the October 2018 SurveyMonkey alternative credential survey results. So I just ran this survey recently, like in the past couple weeks, maybe even last week. You might hear some background noise. That's my newborn Sam. He's kind of sleeping. We'll see if he wakes up. So yeah, this is the folder where I'm holding it. This is the raw export from SurveyMonkey, and here's a TXT export from SurveyMonkey, save as all response data. So even the way I exported it is recorded there, and then the way I exported it gives me this raw file, and then these basic massaging steps, which are done in the Spreadsheet application. They're not done in my code because they're just really easy to do in Excel, and they're not as easy to do in code. So these are done by hand, and it produces this, and this is the one that's actually brought in for programmatic analysis into Stata. All right, so that gives you the background on these files. And then here's my initial do file. I number them like analysis dash to indicate the order. So analysis dash 0 is always the first one, and it's just setting up variables. And then I do some basic exploratory regressions, just linear regressions, and a bunch of comments all the way through, of course. But mainly what this is doing, clear, import the spreadsheet I just mentioned, and then generating variables is the primary task of this. It's always good to have prior Stata code to refer to. So this is the October 2018. And it's actually not just the month of October, it's a panel up through October. So there were two blasts, and then those blasts were answered over a number of days. T is actually at the level of the day, so I have more than just two periods. But like there are two like very, very obvious clusters, so it's not like this is going to give me any really nice nonlinear panel effects, because it's like one day back in February and then like a few days in October. So, but it is technically at the level of the day. And then as I do this over time, I might get some better dispersion across the time axis. And so just preparing the variables for that to happen later. But it does refer to back when I did the one-off where there was no time and it wasn't a panel. So a lot of these variables are the same. So region, income, STEM, and basically it's referring to this file. This is in Udacity Exploratory Analysis under the SurveyMonkey one-off. So just having some code that I can refer to. What does tab do? What does gen do? What does replace do? I work in a number of programming languages, so having that reference is great. There's online documentation as well. And then I use this ref syntax when I want to refer the programmer who's reviewing the code to something external. So it could be like a URL, or, hey, refer to Udacity Exploratory Analysis, right? This is a panel survey where ref above was the original single period survey. And then, here's region, and some of them were renamed, but like, do you work in is still the STEM variable. Do you work in is how SurveyMonkey exported the question. And so I did more of the massaging in the Stata file this time, whereas last time I prepped the CSV additionally. So even in the CSV, it was called STEM. So STEM, Gen, STEM in the last one, and now it's tab, do you work in Gen, STEM, but it's a comparable variable. All right, so that gives you some background on these. I guess I can run through what they are very quickly. obviously time, gender is male, it's one binary. Collectors, so SurveyMonkey has different collectors. Basically, where's the sample coming from? So I used AWS Mechanical Turk for the first time, which was very cool. It was very quick. It was very cheap. There's some question about the integrity of those samples, and that's what we'll find out when we do this exploration. I don't know yet, but I can tell you that I included like just like a random string within the survey, and I had the Mechanical Turk operator input that string, and it came back correct every time. So they're at least genuine responses. It's not like they're just copying and pasting blindly. But then, like, I didn't bother to very finely tune the people who were taking it, like that sample. I don't think I really balanced it. I think I ensured they're from the U.S. I think that's about all I did. Do you work in is asking, do you work in a STEM field? Yes, no, I don't know. Region, it's a region of the United States. This is just in the United States. Which of these industries? So the question is like, which of these matches your industry most closely? I got a bunch of people that answered other. So in the future, I might split other out because other is just a bullet and you just pick other. Later, I might have them like enter the text of what they're thinking, because in principle, they should be able to pick one of the industries. The industries have pretty good coverage. So I think a lot of people are just picking other because it's like, I don't know, like, oh, I work in limos, I don't work in cars, so I shouldn't pick transportation or logistics or something. I don't know what goes on in people's heads, but that's kind of the point of this, right? So heard of Coursera, Lendo, Pluralsight, Udacity, Udemy. So have you heard of these online education providers, these alternative education providers? Just yes or no, they can check multiple. It could be zeros all the way across, ones all the way across. And then, are you an employee? Are you a manager? Or are you unemployed? VOI means variable of interest. So I actually have two variables of interest. One is just the response to question one. Question one is a scale of 1 to 10, a alternative credential can qualify someone for an entry-level position. So if somebody put 10 and they're a manager, then that is a business where you can walk into with no college degree and put your resume on the table. And if you have alternative education, Lendo, Pluralsight, whatever, maybe a portfolio and some talking points, and you can demonstrate your competency, you're going to find that the interview process, they're cool with you not having a degree in that scenario. And because it's a scale of 1 to 10, I can get like marginal and cubic effects. I didn't get the marginal and cubic of the variable of interest, but for the other 1 to 10s I did. So these so-called Q questions, Q1 through 9, are a scale of 1 to 10. So I have linear, squared, cubed for all those. And then what are the questions? I'll run through them real quick. Let me bring up my spreadsheet. So for this, I'm referring back to the raw spreadsheet. And you can see so this is Q1, and then it's just straight to the right. So Q1 is for many professions, alternative credentials can qualify a person for an entry-level position, 1 to 10. Q2, it will soon become fairly conventional for high school graduates to obtain alternative credentials instead of going to college. You can actually argue that's already true, but that's not the point of the survey. The point of the survey is to see what people think. So it's factually true, but do people think it's true? So scale of 1 to 10. When you add up the pros and cons for online education, it's probably a good thing for society overall. Right? Again, as an economist, I can argue like, hey, like here's data, it's a financially good decision. But that's not the question. The question is the American population, how do they feel? Do they feel like it's a good thing? And this is checking my biases, really, because I think a lot of other people are a lot more pessimistic about alternative and online education than someone like myself. And so understanding why and then how to kind of move that needle is a major, major part of this research. And you can see these three are highly related. They're all having to do with basically, are you generally in favor or unfavorable on online education? So actually Q1, Q2, and Q3, the three columns I've highlighted, form an index which is my secondary variable of interest. So I'm specifically interested in, do you think I can get a job with an alternative credential? An entry-level job. We're putting the bar very low. So I'm specifically interested in that. And then I'm also creating a general index. I'm generally interested in your favorability about alternative education. But when I say general favorability, I don't want to just ask, there's the common political question, like on a scale of 1 to 10, how favorable are you? Or maybe 1 to 5, like indifferent, favorable, very favorable, or maybe 1 to 4, like slightly favorable, very favorable. So those are common like political polling questions, but I think they lack substance. It's like, okay, you're favorable, but why? So that's why I am developing an index of favorability across 3 specific questions, right? And so maybe it's like, okay, I'm favorable because I can get that entry-level position, but I'm not favorable because I feel like there's this component missing from the college experience when I do it just online. Right, and so you get some of that why, and then it's like, maybe I'm favorable with alternative education and online education, but I also want high school students to go to college. Like, it shouldn't substitute for that. It should be more for like professional learning or ongoing learning. So you get some of the actual mechanism insight there. All right. Q1, 2, 3. Here's Q4. When you add up the pros and cons for artificial intelligence, it's probably a good thing for society. This is just a completely unrelated new technology, so we're trying to look for innovation bias. Because a lot of times what you'll see is that somebody is just generally in favor of new cool things. Like me, I'm a programmer, so definitely my people when it comes to programming. I can also say my people when it comes to like economists, or I can say my people when it comes to like Christianity or conservatives. So I have all these different biases, but trying to isolate them and break them apart. So wanting to say, hey, it's not just a new technology, it's specifically alternative education. So canceling out the effect of just a general innovation effect. So we're looking for this artificial intelligence. When you add up the pros and cons for cryptocurrency, same thing, right? So N and O together kind of make this like new technology basket. Really, M, N, and O. So that's 3, 4, and 5. But then there's some question about the endogeneity of including this both in my variable of interest, which is the index, and in my right-hand variable, which is this technology index. So there's some endogeneity there, which is like questionable. We can check that in 2 ways. One is regress just the variable of interest Q1 on this technology basket. And 2 is keep the left hand to be the whole index on favorability of alternative education, but just have a 2-question basket. And then there's like, well, what's the integrity of a 2-question basket? That will bear out in the statistics. I think probably you'll see an insignificant effect just because it's like a weak index. But who knows? Like, if there's a really strong innovation effect, you'll catch it with just the 2 questions. And if it is a weak innovation effect, that's a finding in itself. Okay, when evaluating an applicant's education, it's important to check whether the degree was awarded from a U.S. institution. So there's a few things here. So one is, and you see there's some weird encoding, so apologize about that, but none of that makes it into state itself. And none of that is presented to the user during the survey. It's just like an artifact of the export process. So one thing going on here is that if it comes from a formal institution, like a U.S. recognized institution, like you can get student loans through that, and it's accredited. So that is basically the definition of traditional education that is forming a baseline for my research. And then alternative education is like not that, right? So traditional education is like K through 12 public schooling, and then there's shades of traditionalism. So even K through 12, if it's lecture format and it's private school, it's still relatively traditional, but really not a lot of people do that. Like, if traditional is like most people do it, or even a plurality of people do it, then even K through 12 private is already alternative, but it's just not that alternative. Like, think about it, like how weird is that? And compare that to something like homeschooling, where everyone's like, okay, like that's rare. So there are shades of traditional, but really being an accredited U.S. institution, And then again, like public versus private. So public accredited institutions are the most traditional, but then there are also like a lot of like private four-year colleges that are accredited. So that's like still pretty much traditional. So that's one thing that's here is like is that component sorting out the effect of being traditional, and then the other is nationalism. So saying a U.S. institution. So we're looking actually for like a national bias. Have you heard of these guys? Industry, and then you can you can look in the GitHub itself and see where these industries match. I don't want to go through the industries I list. There's like a dozen of them. I consider myself religious. So this is a new addition to the question. So we barely looked for nationalism previously. But I wanted to really drill in and get a lot of the research in political science and in economics shows that there's this left-right political ideology that correlates with a lot of stuff. And then there's also the individualist pro-public axis. So then a lot of times you'll end up seeing like a four, like an X and Y, and it divides it into like sort of like individualist at the bottom, state policy in favor of state policy at the top, and then liberal and conservative. And you get these four quadrants, right? And then one quadrant is like sort of like typical Republican conservative. They're fiscally conservative and socially conservative. Then there's like on the opposite is your typical Democrat who's like fiscally liberal and socially liberal. And then you have these corners, which are sort of like the libertarian corners, where you'll have like fiscally conservative but socially liberal. And then the other corner that I don't even know who exists there, which would be like fiscally liberal and socially conservative. I'm not sure about that. But getting a lot of stuff correlates into that. So getting some insight into that. And then, so here's the general effect if I consider myself religious. Pew has some really interesting research where even like atheists will consider themselves religious in some sense, or like spiritual. And this is also a general effect across religion, right? So there's a lot of research that looks at religiosity. But I personally think that's distinct from, and I think a lot of research says that's distinct from specifically Christianity, that has a unique role in like Western civilization, United States politics. When you say I'm a social conservative in the U.S., that means you're a Christian, basically. When you say, if you're a Muslim in the U.S., then you're likely to be Democrat. Jews kind of split. Actually, no, Jews mostly liberal in the U.S. This is all in the U.S. context. So being religious and being Christian are very different when you get into the details, and it is the details that we care about. And then government regulation helps ensure businesses treat individuals more fairly. So this is checking like, are you basically fiscally or social, or are you fiscally conservative or liberal? So, or are you pro-state or individualist? So if you think government regulation helps ensure businesses treat individuals more fairly, if you think that's like a 1, like strongly disagree, then you're probably libertarian. If you think that's like a 10, then you're probably like, yeah, I guess status is the right word, or at least moderate, right? Not super individualist, not an extreme right winger, not extremely fiscally conservative. You're not trying to devolve powers from the federal government to the state or even to the county or town or individual. Deregulation, again, associated with the right, pro-regulation associated with the left. So splitting all that up. Then we have age. It's not like 2 years old, right? These are groups. They're age groups. Gender, but they are ordinal. They are sequential. Again, income, similar idea. They're sequential. Region is non-sequential. And it might be like sequential by like alphabetical name of the region, but that's useless from a statistical point of view. And device type is like, are you on an iPhone, an Android, a desktop, whatever. I don't really use that, but I am curious. There may be some effects there with a large enough sample size. Maybe like there's like a correlation between iPhone users and high income or something like that, or yeah, who knows? One can speculate. So those are the variables. And the next thing to do is just to run the long regressions. So here is the short expression of the long regressions. And again, these are the linear versions. So this captures all variables related to question 1. Oh, let me finish mentioning. So those were the Q variables that I just walked you through. So then AQ is all of the Q variables except Q1, because Q1 is the variable of interest. We want to eliminate that endogeneity. So I can regress VOIQ1 AQ asterisk, and I'm not regressing on it itself. So that's what AQ is for. And similar idea with EQ. So we have the index is Q1, 2, and 3, and then EQ is all of the Q variables except 1, 2, and 3. And so that's why the expression of the long form is a bit different. So, and then I do put the parameters in alphabetical order. So here it will be AQ, CIS, and then this underscore, you can see the variable syntax. This, like, I generate the variable that I'm actually using here, and then I drop most of the source variables after I generate the variables that I care about. And so really, these are the same two regressions. They're just expressed slightly differently because two of the Q questions are in, 3 of the Q questions are inside of the index. Those 3 being Q1 and 2 additional ones. And actually, I'm not 100% if that 0.48 is right. Let me check that real quick. Okay, yeah, that's right. Excuse me. Okay. So those are the Q variables, and then here are the C variables, which is continuous. So things like age, household income, and the count of providers that you've heard of. So did you hear of Coursera, Lynda? So I add those up, and I make a count. And then these are continuous variables. And then I will also get their square and their cubic, so I can get marginal effects, excuse me, and nonlinear cubic effects. And so those are the C variables. And so that's what you're seeing here. You're seeing Q questions, which is the 1 to 10s. Continuous is are Booleans, so like male. So we have is employee, is manager, is unemployed, is male is the gender variable. So is Booleans. So we have continuous, the Q questions, the is, and then the underscore is just like all the other stuff, a lot of categorical stuff, like I guess these are actually Booleans, so underscore can include some Booleans. Is heard of Coursera, sounds weird. Like collector, STEM, region, industry. Industry would be prototypical. Actually, all of these are prototypical cases of what an underscore variable usually is. So it's usually non-continuous. It's like a categorical variable, right? So these are all categorical. And then Booleans are technically kind of categorical, but really I think this is just a matter of honestly, it just sounded less weird, I think. So yeah, so that is all of this, and then now it comes time. So when I actually do my statistical analysis, I did some basic analysis and I wrote some notes, demonstrate that there's a cross correlation within the variable of interest of the index. So question 1, 2, and 3, they are intercorrelated, and I can show you that real quick. So just linear regression. So they predict so Q2 and Q3 have a point R squared explaining Q1, right? And then here's what we care about. The P's are all 0. So they're like very, very highly correlated. And so it's like a good index, right? It's good. There's like they're explaining the same thing to approximately the extent of 0.3 r squared. And so that is the, if you drew a Venn diagram, Q1, Q2, Q3, and then the overlapping piece. The overlapping piece is like the actual index of favorability towards alternative education. And then outside of that Venn diagram is like, it's not, you're the person, and the person is saying, it's not so much that I'm not favorable in alternative education, it's my effect with the specific Q2, or my effect with the specific Q3. So being able to separate those out and split those effects out. Partialing out, I think, is the statistical term. The partialing out approach. Might be getting that wrong. I'm not super sure. That's Dr. Stratman. Okay. So these are the longest possible linears, and then when I do the analysis, I'm looking for long, weak, max AR, strong. These are the four kind of like critical regressions that I care about when I'm doing my John Van de Veer style exploratory analysis. This is like my style of exploratory analysis. And then sometimes I'll care about a short, but usually the strong is the short. No, strong and simple are also interesting. Simple. But these are more like exploratory, and they're not candidates for the best possible regression. They're more just like looking at, like here's an example of a short regression. Higher Q8 is specifically Christian, proxy for social conservative, weak positive correlation exists. So I'm doing a short regression because I want to look specifically at, hey, does Q8 matter by itself? Does it matter? And then later we'll see like in context in the long regression, does it matter in that case? But if it doesn't even matter on its face, it's very odd that it would matter once all the factors are considered. It does sometimes happen, but like that's super rare. And then it's also really easy to talk about as a simple regression. So here's another way to look at it. If it's significant in the short regression, and it's significant in the long regression, and it's significant all the way through, you have like a significant effect, and it really makes it really easy to talk about when it exists all the way through, because you can say, hey, not only is this effect statistically significant, may or may not be important, but I can speak about it in simple terms that people will understand. If I just ask a person, hey, how Christian are you? That's going to have this correlation. And that's a lot easier to describe than, if I ask a person how Christian he is, it'll have this linear effect, this marginal effect, and then this cubic effect corrected by and interrelated to these other effects about whether or not they're conservative or liberal, or whether they think regulation is effective. So having that simple conversation is really great for communication purposes and for like intuition and things like that. So that is a reason that we care about exploring with simple regressions. But if we're actually being sophisticated, and if we want to know where are the causal effects, that's not a good one, right? This is good for talking. It's not good for like causal analysis or like sophisticated like nonlinear analysis. That's what these guys are for. And really not the long one either. Really these three. So the long regression is like everything. The short regression, short technically means one right-hand variable. And that can be called short or simple. And then sometimes we speak loosely and we'll call something a short regression when it's like a very small number of right-hand variables, but it may not necessarily be one. Like you can see, I did not call, well, okay, I even did it. Here I said regular expression short. But here I have two right-hand variables. So I must be a liar. But no, it's pretty common. It technically means one, and if you have any question, you can just be like, so is it actually one, or is it like two or three? Or what do you mean? And if they're like, well, my shorthand is like 5, it's like, dude, you're like speaking incorrectly at that point. But like, I think this is pretty common. Okay. Weak means, in my book, let's refer over here. So I have D1 long, and then I do interject these exploratory regressions just wherever I find an interesting relation, and I'll make a note. And this is how you can look through my do files. So this is not among the 4 long, weak, max AR, or strong. It's an exploratory. And here's exploratory, and I give them unique names within an analysis. So you might have exploratory 1 from this project and exploratory 1 from that project. It's not like exploratory 1 is unique across all the regressions I've ever done. It's not unique across my GitHub. It's unique across the study. So exploratory 1 means this is like the first regression that I want to call out. It's non-standard. It's just for exploratory because it has a talking point that's associated with it that's kind of interesting. And so here's the note. Country matters, but it is entirely collinear with other stuff in the long regression. So I give you this regression, and I name it, and I just to demonstrate this point. All right, so those are sort of the exceptions, the exploratory regressions. The typical regressions are long, weak, max AR, and strong. So long is just like all the variables, right? And you can see this is from my other analysis when it was not a panel analysis, but it's a lot of asterisks, underscore. It's like pretty much all the variables. And here I even have interacted variables, which I haven't done in my present study. So I may generate some interacted variables. I haven't done that yet. N is for continuous instead of C. I used N because it's like counts is the idea. And I actually don't like this syntax anymore. I like to write out the whole long analysis variable by variable because when I do my round robin reduction, and that's how I go from long to weak to strong, long to weak to max AR to strong, I do a round robin reduction. That's what I call it. It's one by one. Pluck that guy, pluck that guy, pluck that guy. Check some key parameters like R squared, adjusted R squared, some other stuff, and then remove the least significant one at a time. And we'll do that here shortly, and whenever I finish that, that'll actually conclude today's broadcast. But weak, you can see R squared of 0.52. No, that's not what drives R. Weak, yes, here's what drives R. Weak factor model, P is less than 0.5. So in typical statistics, we say you're significant if your P is less than 0.1. If your alpha p-value is less than 0.1. It's arbitrary. It's well known to be arbitrary. And actually, even like statistical associations are like talking about how this is like an outdated mode of thinking and it's incorrect. So it's kind of a standard that exists, but it's people who have studied statistics and econometrics per se, like actually meta-analyzing the sciences, have known for a long time that this is arbitrary and ridiculous. So 0.5 is logical. It's not arbitrary or ridiculous. So if something has a p-value of less than 0.5, technically, it is more likely to have a correlation than it is to not have a correlation. That's the importance of 0.5. If you have a 0.51 p-value, it is more likely that you are a random result than a result due to a systematic effect or real correlation, association, or causal relation. Any of those are all systematic effects. If you're at 0.5, it's exactly a toss-up. And if you're less than 0.5, you are literally more likely to have a systematic relation than not have a systematic relation. So in that case, I include you in what I call the weak regression. Now, an economist can and should argue there are times where we care about a factor where the p is greater than 0.5, greater. Because even though it may be unlikely that there is a systematic effect, it doesn't mean there's not a systematic effect. It just means it's unlikely. And if you weigh that according to the potential economic implications, you may find out that researching that variable further, or as a business, investing into that factor, or at least studying that factor further, gathering more samples, things like that, asking additional questions to do more detailed factor analysis to reduce that question of, is it not? Like, let's cause that 0.5 to move up to a 0.9, and then we're pretty sure it doesn't matter, or down to a 0.1 once corrected for X, Y, and Z. And then we know that, well, this factor alone is kind of like unimportant, but this factor in the context of these other factors, that's a winning recipe for a business to make some actionable result. Okay, and that's what it all comes down to. Why does anyone care about the statistics, right? There was a time back when I was in like middle school or whatever that I just liked math. And I was in math club and it was a lot of fun. It was recreational. That's not me today, and I don't think that's most applied statisticians. It might be your statistics professor. He might just be like an old geek, right? And that's cool. But if we care about being an action-oriented business, like in the professional world, or even in my private life, my own investment decisions, my maintenance of my own household, growing my income, reducing my expenses, financial optimization and non-financial optimization, because as we all should know, economics encompasses much more than finance and accounting. It's not a purely financial game, although we often reduce things to financial expression for the simplification of mathematical calculations. But non-pecuniary advantages can be assessed in this way. That's what it comes down to. That's the point of doing all this, is we want to identify those factors where I can move the needle on something I care about. The thing I care about in the context of this survey is, hey, like world, we should be able to use alternative credentials because they evidence skills more effectively. The education programs which endow skills more effectively. They are cheaper, they are quicker, so we don't need generations wasting years, like me, going through 4-year, master's, PhD. Like, how much time did I waste? And like, let's be real, I was smart when I started it, right? And that sounds kind of flippant, but it's largely true. And that's not to say I had acquired all the skills that I have today, but the potential was always there, and it could have been more quickly and easily identified, and it could have been more quickly and effectively trained, and it certainly could have been done cheaper. I won't tell y'all, my school debt, but it's immense, right? It's atypical. Along with my atypical investment of time, there's an atypical investment of financial resources. And all of that's extraneous and superfluous, and it need not be done. And it's wasteful and inefficient. And so that's the thing that I'm trying to move the needle here, is if we can get the professional world, and that's why I really care about is that variable is manager. If we can get because they're the ones making the hiring and firing decisions. If we can get those people on board with alternative credentials, then we can stop telling our kids they have to go. Because if they're going to hire you, whether you go or not, right? That's the reason we tell our kids you have to go. That's the reason my parents told me you have to go. Because you want that job. And the people making the hiring and firing decisions want to see it. And that's all correct, although it's less correct as we move forward in time. But it's certainly been correct in the further past, and then even in recent memory. And arguably in current memory, in the present. That's what we're trying to measure. Okay, that was a fun digression. So that's the long is all the variables, and then we pick out one by one the least significant, and we reduce it to the weak. And weak is all of the surviving parameters, all the surviving variables have a significance of better than chance, of less than a p-value of less than 0.5, a significance of better than chance. That is to say, there is probably an effect, strictly speaking. 0.5, more likely than not, probably an effect. And that is the logical use of the word probably. And that's why 0.5 is non-arbitrary, unlike 0.1. So there is probably an effect with these weak variables. All right, now max AR. So AR is representing adjusted R squared. P is at the level of the factor. R is at the level of the model as a whole. So R squared is, roughly speaking, how well does the right hand explain the left hand? So if we go forward into a business case, and the regression you have on screen, VOI employed. So this is whether or not someone's employed. So this is just a Boolean. So this will be easier to explain. If it comes out 0.6, then there's roughly a 60% chance that this person is employed. Okay, if it comes out 1, that person is expected to be employed. It could come out more than 1, just due to mathematical artifacts. If it comes out more than 1, they're expected to be employed, or perhaps to be gainfully employed even, depending on how you want to interpret that. They could be employed and then like some like higher than average income expected, something like that. But basically they're expected to be employed. If it's 0 or less than 0, you're expected to be unemployed. The right-hand variables are those things. So let's say you're a person, I don't know you. Your name is Jim. I'm going to find out all of this stuff about you. What's your age? Then I'm going to square your age. Then I'm going to cube your age, right? And these are all going to factor in. They're all going to have their associated coefficients. So I'll take those numbers that I just found, your age squared, cubed. I'll multiply them by some coefficients. I will add them. I will find some other stuff. I forget what NDET means, but EDU is your count of education. So it's like how many years of education do you have? And then this is the cubic. So if you graduated like high school, then that would be like 12 cubed. Some coefficient, years of experience, number of languages that you speak, English, Spanish, whatever, Chinese, whatever. And so on and so forth, right? So I will gather all of this information about you, Jim, person who I don't know. After I gather just those things, no additional information, right? I probably didn't even see you in person. I just have a sheet of paper with facts about you. Because if I see you in person, I already know some things about you, like your gender, like maybe you look like you're blind in one eye. So that would be information which may or may not be included in the right hand. Just all sorts of stuff. So just the information on the right hand, nothing more or less. But I have those information on the right hand. Then I calculate the result on the left hand, and then r squared is basically going to be a measure of error at that point. And it's going to say very roughly again, hey, if you made a prediction like this 100 times, 52 times, we think you'd get it about right. So if I did this for 100 Jims, Jim, Nancy, Sally, all these different people, and I did that regression, whether or not they're employed, and then at the end of the day I said, I think, because I said you have a, that's going to be so roughly, then it's just not correct anymore. But you can think about it intuitively like this, but this is actually not correct. Because I said that 0.6 is like a 60% chance of being employed, but in the real world, I wouldn't be predicting that you're 0.6 employed, right? In the real world, I'd be predicting you're employed or not. And so that difference is actually going to screw up the interpretation of r squared right here. But very, very, very roughly, to the point that it's not actually true, but at least it can help you think about it. For 100 of those predictions about whether or not you're employed, we think you'd be right 52 of the times, and then wrong 48. So 52% of, and here's more technically, 52% of the variation in the left hand is explained by the right hand, which is the collection of all factors, all explanatory factors. I actually like that interpretation a lot more because it's actually correct, rather than the applied example, which is hopefully helpful for you to think about, but it's actually not technically correct due to the rounding effect. So that's that. So that's the weak model. Then we again, even though we're all under 0.5p, we're still going to remove one by one the weakest. Okay, and then we're going to get to a max AR, which is the maximum adjusted r squared. So I told you about r squared, which is the explanatory power of the model, and it's the raw explanatory power of the model. It's unadjusted. So here's the trick about r squared. It never goes down. I can always add shit in, and it will always explain, maybe negligibly more, but it'll always explain more. It will never explain less, because you still have the existing variables. So why not just have like 10,000 variables? But then it's very unhelpful for an actual business, because the actual business wants to say, hey, where's my return on investment? And when I'm interviewing candidates like Jim, I don't have time to gather all of this information. I need to know where are those useful bits of information? Which factors are most important? this is basically starting to be, this is related to factor analysis again and model analysis. So which factors do we actually care about in the return on investment sense? So technically everything will raise my explanatory power with a large enough sample, but I want to get bang for my buck. So adjusted R-squared penalizes you for having more factors. And it just, I can look up the function for adjusted R-squared, but it is a relatively large, it's not like arbitrary. It's like a nearly, it's like a unit effect, like one factor, one penalty. I don't think it's a linear effect, but it's a unit effect. Anyway, you can look up the function for adjusted R-squared. The point being, whenever I maximize my R-squared, that's always going to be maximized in the long regression. Long regression is going to have more R-squared than the weak regression, right? But what's the delta there is a bunch of factors that are less than weak. Like, they're not useful factors, except for the case where an economist might prove, even though it's unlikely, it's extremely, extremely important, and therefore we're going to, right? So I talked about that. We're going to invest in researching that particular factor further, but it's unlikely to have any correlation. So if it doesn't have a correlation, then obviously, like, it's non-causal and it's not going to be useful for moving the needle. So we care about the factors in the weak regression more than we care about the factors in the long regression. Even though the weak regression is always going to have less than or equal R-squared, the factors are going to be better, okay? And so it is with max AR. Max AR will have less R-squared than the weak regression, but it will have more adjusted R-squared, and that's exactly what the point of it is. Sometimes you'll even see a sign reversal. You can have an adjusted R-squared that's so bad that it is negative. Even though your R-squared may be maximized, your adjusted R-squared could be negative. So maximizing the adjusted R-squared is going to really concentrate your explanatory power into many fewer variables that are much more valuable. And that's why we care about it. It's the same logic in moving from long to weak, is the same logic in moving from weak to max AR, because we have fewer factors, but they're better factors. They are nutrient-rich factors, to use a nutrition analogy. Okay? So we're going to maximize your adjusted R-squared, and really that's probably your best model a lot of times, depending on the standards, standards in the industry for statistical analysis. A lot of people will say that the maximizing your adjusted R-squared is like one of your, it's like your go-to, right? It's not necessarily, it's not necessarily your best model, but it's sort of your go-to model. And there will be cases, let's talk about the strong model. There will be cases where a strong model or a simple model is preferred, and they're often preferred for being able to easily explain things, or they may be preferred because collection of data to apply and execute the model favors a shorter, simpler model. Those are all valid. But you don't have, and there are arguments for the weak model as well, where it's like, hey, you left out some variables that we think have an effect. Why are you doing that? We think they're going to have an effect. And a good response is like, well, they may have an effect, but it's like a very tenuous effect, and it's really expensive to collect all those variables. That's a great applied response. But from a theoretical perspective, where there's no cost constraint just on the thinking of it, you wouldn't want to exempt those from at least like logical analysis, right? But then no one is going to pull for the long model where it's just like, dude, that's just everything that you collected, whether or not it actually matters. That's what your long model is. So each of these sort of critical models has their use case. But your go-to is usually your adjusted R-squared, because it is that bang for the buck, right? Until you factor in dollars of collection, before you get to that point, assuming those are equal, your adjusted R-squared is your best bang for your buck. And then there are some additional complexity metrics that I came up with. I don't know how standard these are. That would also speak to the bang to the buck situation. So Q complexity is how many questions do I have to ask? So when you're working with a lot of derived variables or categorical variables, I can actually get you a bunch of right-hand variables with one question. So here's an example where F complexity is 28. There are 28 factors in this exploratory model, but there's only one question. The question is, what country are you from? And I got 28 answers. So that's a case where I can get a lot of information from few questions. And that's a case where, now this is a shitty model, the adjusted R-squared is negative, right? In this case, I wouldn't want to use that for seeing whether or not you're employed. But there are cases where the best question I can ask you is like, what country are you from? And that's going to give me the most insight in a quick and cheap fashion. You know, you have to pay to administer surveys sometimes. Even if you're in an interview process, you have to pay with your time and with annoying your interviewer and your interviewee with a lengthy process. So coming up with a concise, like powerful, like dense, like power dense, like informationally dense process is like really valuable. And it's valuable not in this abstract sense, but literally in dollars and literally in time and other, like it's actually powerful. All right, so the strong model. So strong. Exploratory. And here's D1 strong. D1 is referring to the sample. That's not so much relevant for my present analysis. It was relevant for that analysis done earlier in the year. So D1 strong is the name of this model. It has this count of samples. When you change the factors in a model, not everyone answered all the questions. So when you change the factors involved, you could have sampling effects that can affect your significance. That's super important, right? Sampling effects are really important because when you have large samples, you can be more confident about the results. When you have few samples, you cannot be as confident. R squared, explanatory power, adjusted R squared, explanatory power penalized for having too many factors. F complexity, how many factors? Q complexity, how many questions do I need to ask to get that information? Strong factor model P less than 0.1. So this is coming back to the like professional standard of 0.1. And then some people, and then it's like double asterisk for 0.05, triple 0.01, and then and you can go 0.001. And for medical studies, they care about like more significant than that because, hey, like I have one fucking bacteria and it still killed me, like shit. So in certain medical trials, like you need like 99.9999% confidence or whatever, bacteria killed or whatever. Or in chemistry, not just medical, in chemistry as well, in certain sciences. So that's why I have this strong model. So what's the standard for strong? It's just the professional standard of 0.1. And then you can reduce it further, you know, and get to a simple or short model that has like the one or two most important factors. But really, by the time you do that, you're cutting your explanatory power down because even your best factor often cannot explain much. So you want to balance between a simple model, where the strictest sense of a simple model is one factor, but the general concept of a simple model is fewer factors. You want to balance between a simple model and a high explanation model. So that balance is often, like I said, your go-to would be to maximize your adjusted R squared. But then, like certain people, depending on which professor you're talking to, he might turn up his nose and say, well, you don't even have 0.1. Your p-value isn't 0.1, motherfucker. So you can show him this model. You can be like, dude, look, the difference between my AR maximizing model and my strong model is like 2 factors, right? So if you include these two, so like, don't you think these 2 factors are interesting? You include these 2 factors and you get like a bunch of like explanatory power for just 2 factors. They're like, oh, well, that kind of makes sense. Ha 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 ha. Ha ha. Or the other way around, like, hey, all of the p values are 0.1. But if I cut just this one factor, now all my p-values are under 0.05, and my r-squared only went down like 0.01. So like maybe that's an even better model. But here's your point of reference. The strong model is a widely accepted, logically backed reference point from which you can discuss further. And so that's it. Those are the 4 models that I care about. Here I did REG, that's linear. You can see I continue on with logit. So I do nonlinear checks, logit, probit, some other stuff, but it's the same idea. So this is the long logit. There'll be a weak logit, and rinse and repeat. So I've sort of walked you through the idea of the analysis, and that's pretty much all I have to do. What I will do now is I will just I'll just execute what I've been talking about. Get the long, weak, max AR, and strong. And so that's what I'll be doing for this next section. You'll see, maybe watch it for the first model or two, and then it's sort of just like this monotonous process where I just one by one remove a factor. So you'll get to see me enter a bunch of stuff into Stata, and you might think that's cool for a minute, and then it might get boring. But let's do it, or you're welcome to stick around for the whole thing. Why not, right? So I'm going to start, long regression for easy copy and paste. You can't just copy and paste this guy because you can't remove one by one factor here. So this is the initial expression, but what I'm going to do, and we're going to start with the VOIQ1, and we'll repeat it for VOI index afterwards, although I probably won't be recording that piece. I think I'll just record the VOIQ1. And I think I'll just record the linear getting the 4 models for the linear. So here's Stata. So I'm going to paste my concise expression. Boom. And look at all these factors that it knows that I meant to include. And a bunch of them are collinear or whatever. Okay. So first thing I'm going to do is I'm going to create analysis -1. What do I want to call this? Linear. .do. And I'll call this VOIQ1. VOIQ1 linear. Right? So VOIQ1 linear. Come over to my IDE. Refresh. Control P. Type. Had a little dash. So that little moving dash was like, hey, I'm loading a new file. Right, so we got this empty file. Okay, and the first thing I'm going to do is just write out the regression. There was a quick way to do this, but I've forgotten it. Copy. Oh, you know what it might be? It's just like copy them all here. Copy var list. Let's see if that's it. Yeah, way faster than typing all those by hand. Respondent ID we're not using, IP address not using. So I should have dropped all these. Q. Okay, so I didn't drop the Qs, but we don't actually use the Qs, so I'll just delete them. Device type, we don't use that. All right, collectors, I need those. Stem, region, I need all these. Time. Region 8, industry, love those. Heard from, need those. VOI Q1 should not be in the right hand. VOI Q1. All right, and AQs are referring to VOI. Let's check that. I think so. Right, so AQs go with VOI, EQs go with index. Okay, so I'm on, here's AQ2. We'll keep going. Need all my AQs. I don't see my nonlinear AQs. Let's check Stata. They might not have been built. So here's EQ squared and whatever AQ, yeah, it doesn't exist. Okay. So whatever STATA session I had was not identical to running this script, so we're just going to run this script fresh. Do GitHub. Boom. First thing it does, clear it out, and then it runs through all these regressions. Actually, I could separate out those regressions so that I wouldn't have to hold the enter key, but it's not a big deal. So this is the var list that I care about, AQ. All my AQs are in there. Copy var list. All right, so reg VOI Q1, space paste, and let's start over. Don't care about you guys. Delete that, save. Okay. Collector stem region. Love all that. I love industry. Collector stem region, industry. Heard of. Is employee, is manager, is unemployed. VOI Q1, delete this guy. AQ with squared and cubed. Now we have VOI index, which I don't want in here. Although it would, yeah, no, I don't want that in there. VOI index. And I don't want any of the EQs. You might think it'd be useful to ask, hey, what about the relation between VOI Q1 and VOI index? But you can just ask that just by regressing Q1, Q2, Q3, which is the short regression we already did in analysis 0 when we were establishing the intercorrelation. Okay, so CAGE is continuous age, continuous income, continuous or count, either way, whatever you can think of it. It's both. And is that the end of it? That's the end of it. Cool. So this is our long regression expressed in long form. Now you can appreciate why the concise expression is better. Is because you can actually read it and you can type it quickly. I'm not even going to put that here. So this is going to get rid of this. So the analysis.do that I'm referring to, no, I don't care about that. The analysis one, yeah. D1 long. So I'm just going to name it, and how I'm going to take this little template, regression exploration template, and sometimes I'll do a note, just for this, like a script note up at the top. So this will be note VOI Q1 linear regression analysis. Okay. Long, weak, max, AR, and strong. Long, weak, max, and AR, and strong for VOI Q1. Also some exploration, some exploratory regressions. And so I think this will actually be how I name it. VOI Q1 long. VOI Q1 long. Okay. And then, so let's look at the, now the STATA results should be identical. Okay, and then I can refer to here. Identical to look there for long reg for easy. Okay, so these should be identical. And then I'm going to actually do the same over here, and that will be called VOI index, VOI index, VOI index long. Okay. All right. So look at my stata. So this regression is VOI index. This regression is VOI Q1. Okay. The R squared and stuff that I had was with the nonlinear AQs exempted. So this actually has more explanatory power. 0.53, 0.297, which is 0.30. So 0.53. So 0.53. And 0.30, and then this guy is 0.43, 0.19, 0.43, 0.43, edge AR, edge stars, 0.19, 0.43, 0.19. So overall, it appears easier to explain Q1 than it is to explain the index. So that's another reason it's interesting to have two variables of interest, same analytical question, right? But also what we notice is that 0.53 is in excess of 0.5, which means most of the time we are going to be able to predict your response to Q1 based on the right hand. So that's a good result, is if you can get an R squared over 0.5. It'd be much, 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 much better if I could get an adjusted R squared over 0.5. It's not, well, you know what, it could happen. It would be, we'll see. If my R squared is 0.53, it may be possible in principle to get an adjusted R squared as large as 0.53. It's never going to be higher, but at least from an analytical mathematical perspective, it could potentially be equal to, it's unrealistic though, like in real world, it's probably going to be under 5.3. We'll see. Could be upper 0.4s though, and that's still pretty damn good. That would mean, just look at it from a return on investment standpoint. You don't need to explain the whole thing. You just need to cut risk, and that alone is valuable. If I can move the needle with 40% confidence, so let's say I knew I could do this with $1 and it would increase acceptance of alternative credentials by X. That would be an R squared of 1. Now let's say I have an R squared of 0.4. That means I do this with $1 and I'm 40% sure, right? 40% sure it's going to have X. Or in, rational expectations, you could just say, I'm 100% sure it's going to be 0.4X. If you get the causal analysis right. That's the tricky part. It has to be causal. It can't just be a correlation or association. And so that's what we're doing. But you can see that even though one would be cheaper, I would be perfectly happy as long as the result is consistently 0.4. As long as that correlation is causally established and everything, I'm happy with 0.4, 0.5, 0.6. It could be 0.1. I'm fine with 0.1 or 0.05. The actual R squared itself, or even the adjusted R squared itself, doesn't matter as much as the overall establishment of a systematic causal relation. That's the part you care about, systematic causal relation. Other than that, it's just modifying the return on investment value. And higher is better, but like if you know that there is a way to get it done from a business perspective, and it just turns out to be a little more expensive than you thought, that's like not a big deal. The big deal is, can it even be done? Right? Can we even influence the acceptance of alternative credentials? If we can prove that it can be done, it's just kind of expensive. Like that's a lot smaller of a hill to climb than, shit, dude, honestly, we're not even sure this thing's going to work. Like MOOCs, it sounds kind of weird. It sounds like something a cow might do. Like, I don't even know if we knew that. But to have an R squared that's like, the other thing is you don't want an R squared that's too low, because then it's questionable if it's even statistically significant at all, or if it's a result by chance. So if your R squared is under like 0.1, and that's just like kind of a guess rule of thumb number. It's not like a real thing. But if your R-squared is under like 0.1, you might have an academic who's like, dude, you probably just have sampling noise. Like you probably don't have a result at all. Like you can throw any bunch of random samples together and pick the most correlated factors within the sample and get a cross correlation of like better than 0.1. But over 0.5, you see as your R-squared goes up, it's harder to make that argument. It's not like this is some random correlation. It's like most of the variation is associated, like more than half. Like that's pretty good. Okay. So we have this VOI Q1 long. What is the N? Okay, and we're actually checking to make, so here we had 0.53, 0.30, 0.53, 0.30. This F complexity, I don't know. I didn't count it out. Q complexity, I don't know. I'll do that later. I would just be counting. So here's like 1, 2, 3, 4. That's how I get the F complexity. And then I have to go back and check the number of questions, right? But I'll do that offline. But I don't want to just write 0.53 and 0.30. I want to confirm, and then also this N. I want to confirm those. Okay. So 0.53 and 0.30 we got from entering in. Let's do it again, just for safety's sake. VOI Q1. Okay. We enter it in 0.53, 0.30 after rounding, 0.27, 0.297. Okay? Great. Now, I should get an identical result pasting this in, or else I copied the var list incorrectly. 0.53, 0.30. It's just a matter of data entry, which we poo-poo, but you enter the data wrong, you screw up your whole analysis. So I can't emphasize it enough, like triple check that stuff. I don't care if you're the smartest guy. Like, I'm not the smartest guy, but that stuff freaks me out because I can have this great analysis and it's like, dude, you left off like one important factor and it screws everything up. Okay, having done that, what was the N? N is 188. So my overall sample is like mid 300s, but the sample which satisfies all of these factors simultaneously, permitting the analysis, is only 188. So that's one of the benefits when we cut one factor by one factor. We will be upping our sample, the effective sample, because not everybody answered all those combinations of questions, right? Like not everybody from region 3 had the same amount of variation on it's all about those combinatorial variations. It's not as though everyone answering question 1 and everyone answering question 2 is good enough for a real analysis. You can do a basic analysis like that, but a real analysis, you need to have for every answer to question 1 a different answer in question 2. And then you need to have significant samples within those combinations. And this is something a chi-square test is very good at doing more precisely than the way I'm saying it. But basically, you're going to get insignificant factors if you just didn't have a lot of results for that combination. There just wasn't a lot of samples. So that's why it's insignificant. It's not that the correlation is not there. It's that we can't be confident because we have a low sample. We have sampling effects that are reducing our confidence. Oh. I think I explained that very poorly. I think someone needs to kill me. Cool. And you see how we have collector 1, 2, 3, 4, 5. Yeah, I'm just gonna let it. I'm just gonna let it go. I'm not sure I can explain it better than that right now. So yeah, so this is the long regression. So let's go one by one and pick them off. So this is the fun part. So we know these guys we can remove because they're collinear. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Literally all of them. Okay. Got Tina texting me. Oh, she's just checking on me. Sweet girl. Okay. So this is going to be VOIQ1 week. And put question marks in these because we haven't done them yet. All right, but we do know that we can get 1, 2, 3, 4, 5, 6. We can get rid of all of those factors. I can even do this so that whenever I finally get around to counting that one, I can just like quickly count 1, 2, 3. Okay. Oh, you know what? A quick way to count these factors. I just thought of this. I don't think I was smart enough to do this in the past. But if I can just utilize the Excel counting. So here, data, text to columns, delimited by space. Boom. And then $73. That's a time saver. That's a time saver right there. 73, boy. All right. So this would be 73. I like that trick, man. Note to self. Good thing I got it recorded. Okay, 73 minus 6, right? What else is collinear from STATA? STEM 3, region 8. Collinear, just so you know, means it's perfectly predicted, contingent on all the other factors being present. So it's essentially extraneous to the model, given our sample anyway. If we had a different sample, that might not be the case. STEM 3, region 8. STEM 3. STEM. Let me do it like this. STEM 3. Okay. Right, region 8. So there's no variation in that when I was talking about the combinations of question 1 and question 2. For each answer of question 1, you need variation within question 2. This is alerting us that within our sample, STATA is doing all that. Pick. It's doing all that for us. God bless STATA. It's saying, hey, given all your other answers, there's no variation within STEM 3. Like, it's always the same result. So you don't even need that factor. It's collinear. It's extraneous. But that might be not be the case with a different sample. STEM region, industry 1. Okay. Industry 1, heard of Udemy. Ooh, really? It actually makes sense. Heard of Udemy. No, actually, I'm not sure that makes sense intuitively. Heard of Udemy. Could just be coincidence. Is unemployed. Is unemployed. Cool. All right, so we removed all of those. 1, 2, yeah, I'm not even going to do that. I'm not even going to do 73 minus whatever. I'm just going to do my Excel trick whenever I narrow it down. So this is our baseline, but that would give us the same result. We need to actually, because we only removed collinear ones that were omitted anyway. We need to actually find who has the highest p-value and remove that guy. So here's 0.969. Region 2 is our best so far. 0.963, no. Although it's going to be eliminated soon, probably. So keep it in mind, because like next round, we're probably going to grab it. 0.969, 0.977, 0.977, AQ2 cubed, AQ2 cubed, 0.977, 0.977. Okay. Can anybody beat that? No. Probably all these 0.9s are going to get cut. So AQ2 cubed. Later, dude. All right, now this we actually have to run again. It has to get recalculated now. Boom. You can see our R-squared didn't even really, like, neither of them budged noticeably because we removed something that had a huge p-value. And when it has such a high p-value, it's the mathematical way of saying it almost doesn't matter, right? Like, it's probably not even related to anything going on here. It's just fucking around. And that's never actually going to worsen your R-squared. Even though you got these random data everywhere, it's never going to worsen your R-squared because your least squares optimization is going to filter that out. It will worsen your adjusted R-squared because it's basically like you have this additional factor that's like not helping. So what should have happened is that our adjusted R-squared should have gone up, just probably not noticeably. And then our R-squared may have gone down, but probably not noticeably. So here's region 2. Got 0.97 is the highest right now. So these p-values will change every time the model is run. It's not like they stay, right? So you might have one that was the next highest, but it's no longer the next highest because two factors were explaining the same thing and their explanatory power was shared. And then when the secondary factor was removed, that explanatory power was attributed to the surviving factor. So that surviving factor becomes empowered. And sometimes when it's empowered to the extent that it's now significant, although it was previously insignificant. So this guy wins, region 2. Region. And once we get cruising, just doing this round robin type of thing, it doesn't usually take that long to go around through it. So we got 0.96 industry 2, 0.96, 0.96, 0.96. So one of the scary things is that because of what I just mentioned to you, the way that factor elimination can result in empowering other factors, there is a certain path dependency in this style of factor analysis that if you like read it wrong, right? If I'm like reading, it's like late at night and I like 0.96 and I scroll to the left and I pick industry 3 instead of industry 2 or something. Or even if I pick a 0.95 and I miss that there's a 0.96, there's a certain path dependence which can happen, which can affect downstream models. It usually never survives. Those downstream effects usually don't survive into a strong model, and often not even into the max AR, but they will sometimes, and dare I say often, survive into the weak model. Okay, got rid of industry 2. I don't see any 0.9s remaining. Oh, I think I saw one. 0.9, 0.9. Here's a 0.9. Or a Pluralsight. Like, it almost doesn't matter if you heard about Pluralsight specifically. It more just matters if you've heard about these all together. Although it really matters if you heard of Linda. That's weird. Cool. So I heard of Pluralsight is the dude. And you can see how scary that is. I keep deleting the wrong one. Good thing Control-Z exists. Make sure I still got it in the long model. Okay. Got a 0.86, the highest I saw, 0.8. Right, okay. 0.86. 0.87. 0.87. And you might go, AQ5, what is that? You can create labels or you can just refer to the spreadsheet. Because I'm kind of curious, like, oh, this is the first Q question. Like, this is the least important question, arguably. AQ5. So let's see what that is. Just one, two, three, four, five. This is the least important question, is the cryptocurrency question. Look at that. Do you contribute to hiring? 1, 2, 3, 4, 5. Now, it's really not quite fair to say that that's the least important because, again, this is a case where its explanatory power is being shared because it has some common factor with artificial intelligence, right? And with online education. So that technology bias is shared among the three. So in any survey that didn't have Q3 and 4, Q5 could be much more significant. But because 3 and 4 exist, Q5, you're only getting the marginal benefit. It's like, given that these questions are already asked, what additional benefit do I get from asking this question? And the answer appears to be like not much at all. Like you don't even really need to ask that question if you have the other two. Sounds to me kind of like another way of saying there's definitely a technology bias. If these two matter, you don't even need, you already know what the answer to the other one is. Sounds kind of like a technology bias exists. Oh, right. 0.84. No, it's 0.87. Okay. Okay, yeah, nobody can beat that. AQ5, AQ5. And it's the linear effect from Q5 because the marginal and cubic effects survived so far. Those are likely to fall apart eventually if the linear effect fell apart. Okay. All right, so get rid of Q5, AQ5, AQ5. Okay. 8.2, 8 points. I saw an 8.7 somewhere. Industry 6. You see it like went up because the relations get scrambled and recalculated whenever you remove something. So stuff can go up. It actually became less significant. Okay, so industry 6, bye-bye. So what is this industry 6 that doesn't matter at all? Let's find out real quick. Here I'm within my actual SurveyMonkey showing you that. One, two, three, 4, 5, 6. Is it IT? I'm not actually sure the 6th one correlates to industry ID 6. It's inconvenient. So it seems like the answer is IT, which seems pretty counterintuitive to me. If I wanted to be super sure, I could download it without the numeric value and instead actually have the string value. So this is exported with the string values. And then here's one way we can match it. Let's get respondent ID, this guy. So he's only found once, right? No, I need one with 6. Industry. So let me go to the other. Industry, industry, industry. Six. So this guy, unique respondent. Okay. We go in this sheet, unique respondent. All right, and going over. Yeah, IT. So which of these most closely matches your profession? So we have 2 ways of matching 6 with information technology. So that is pretty surprising. It wasn't the least important industry, but it was down there. I think I might have deleted like 1 industry prior. Actually, I can check that. So industry, oh no, I already deleted 1 and 2, so now we got 3, 4, 5, then deleted 6, 7, 8, 9, 10, 11, 12. So 1, 2, 1, 2, 6. So it was like the third. It was like the third least important. And again, it's not that working in IT per se is unimportant. It's that working in IT is unimportant, assuming that you already have all of the other information in the survey. So it's like the marginal importance is very small, not the total importance. Because I already asked things like, what's your income? What region do you work? What's your gender? Do you work in STEM? So those questions can already kind of explain whether or not you work in IT. So actually asking directly, do you work in IT, only adds marginally to the picture. And apparently that marginal explanation does not relate to whether you think an alternative credential can qualify someone for an entry-level position. That marginal effect has a weak relation to that question. Checking on little dude. Okay. And we're still at 0.53 r squared, but our adjusted r squared has come up significantly. So 0.82. Looks like that's the loser to me, 0.82. Region 3. Hmm. 8.1. Region 6. Seven, 7, 6, 7, 7, 6, 7, 7, 6. So the cubic effect on income is relatively weak. And see, that's interesting because we know with a large enough sample, the cubic effect on income is related to a lot of this stuff. So it's almost like the marker for whether something is actually related. It could be up as high as the upper 0.7s, not just below 0.5. 0.76. Yeah, so now 0.76 is the new winner. So this is a fun one because time, at least at the level of the day, time doesn't seem to matter. Now I could create a Boolean that groups all of small t together and all of large t together to get kind of like that cluster analysis to see overall one survey. But really I'm fine with removing time, and I'm fine with saying it appears that, at least based on our low sample size, again, we have a small sample of time. I think there's something like answers coming from like 4 different days. Given our small sample of time, for like overtime, the pattern doesn't seem to be changing. So basically the result is whatever was found, whatever was the case in like back in February is like pretty much more or less, it's like pretty much still the case here in October. So the course of this year has not changed these results significantly. That's what we're saying logically by eliminating time as an important factor. It actually appears to have a negative coefficient. And I could add marginal and quadratic there, but like we only had like 4 different samples of days, so I'm not really comfortable doing that. I'm most comfortable saying not that we're sure time has no effect, but that we had so much little variation within time that we didn't pick up any effect. Both of those. Yeah, there's no clear effect. So that's a fun result. So we're eliminating time. It's at least worth noting. Note. And I actually think time has an insignificant impact on attitudes was an initial result during my cursory analysis in the simple regression. Okay. Cool. X5, X9, that's 7, 4, or 737. 737, so AQ6 cubed. AQ6 cubed. X7. 872. Here's an 872. Oh, 945. So AQ6 shot up into the 9.9s. So that'll happen a lot of times when a linear, marginal, or quadratic is disrupted. The entire chain gets disrupted and thrown out. That happens sometimes. AQ6. And other times you'll see a consolidation where the cubic and the linear, or the cubic and the marginal go away, and the linear is really still important, or like just the marginal or something like that. So AQ6. I can't imagine that logically it wouldn't make sense that AQ6 linear and cubic would both be thrown out, but the marginal effect would survive. So I assume AQ6 squared is going away soon. 687. Six, 8, 7 is the winner. 6, 8, 7 is the winner. So industry 11. Okay. We got a 728, 728, 728. 7, 2, 2, 8. So industry 10. All right. Six, 9, 8, 7, 5, 9. 5, 9. 759 is the winner. Industry 4 is out. Industry effects seem to be dropping like flies. 7, 5. Industry 5. Okay. 7, 7. 7, 7. So STEM 1 actually doesn't. STEM 1. Okay. STEM 1. And I think STEM 1 was yes. So I think it was yes, no, unsure. So yes, no, unsure can be encoded into two binaries. Because if they're 0, 0, then the third is implicitly true, right? So, but just one of them surviving means that's the only important one. So it appears to be that the only important one is if you say no. There's not a significant difference if you say yes or unsure, but if you say no, I'm definitely not STEM, then there is a 0.3, which is not wicked significant, but it's at least a weak effect, and it's a weak negative effect. So it's not that saying yes, I'm STEM is awesome. It's that saying no, I'm not STEM is decidedly not awesome. And I think that accords with a lot of what we know. There's interesting stuff like digital art is digital art STEM? So like what I do, programming, is decidedly STEM, but then the digital art, like visual designers, there's this thing called STEAM. So it's like science, technology, engineering, art, and math. And a lot of people argue, so some people will argue, well, digital art is still technology, but technology could be anything. So other people will say, no, like UX design, website graphical design is much more STEAM than STEM. So then a person faced with that question, are you STEM? They might say unsure. So it's plausible that like there's a low effect between yes and unsure, but that if someone is like very sure, like no, I'm definitely not STEM, whatever an example of that would be, like there's a more clear effect there, less noisy effect. Okay, you can see we're still rounding to 0.53, but now we've gone from 0.3 to 0.38 in adjusted R-squared. So our adjusted R-squared has come very far up without our R-squared going down very much at all. So we're consolidating our factors down to the ones that matter. 0.73. Okay. So 0.73 heard of Coursera. Wait, 5.3, 0.61. 5.3.61, 6.8. So 6.8 is the loser. So here's finally that AQ6 squared effect. He tried to hang in there, but we finally got it to admit that Q6 just doesn't matter at all. What is Q6? This is Q1, 1, 2, 3, 4, 5, 6. So whether the degree was awarded from a U.S. institution just doesn't matter at all. And that's pretty cool, because what that indicates is that if there is a nationalistic bias, one of the following things is happening. One, it's just insignificant and or it's not there, which would be great. I would love a world where there's no nationalistic bias. That would free the economy internationally and improve a lot of things with regard to our education system. We can have like alternative education already sees over borders. So if there's this attitude in the US that no, we need a US accredited degree, that's very pessimistic for alternative education. Whereas if there's this global outlook like, hey, you may be from India or China or Africa or Europe, but you still got that global Udacity education that's globally recognized. That's really, really positive for alternative education. And it's positive for the economy, because think about it. If you can get a worker from like Eastern Europe or Russia, and he took the same course and he performed to the same degree, but you can get that guy to work either remotely or to even move over to the United States. You can get him for a lot cheaper, so you're getting the same quality of a programmer for potentially a lot less money than if you hired somebody out of like, the Bay Area or New York City, or even where I work in the DC metropolitan area or Chicago. Austin's a growing one. Florida is also a growing one, where it's like we're in the US, but we're still kind of like techie, but we're still kind of like cheaper. So I think we already see pressures to get away from these really expensive, prototypically techie areas like San Francisco, Bay Area, New York City. They're way too expensive. Right, way too expensive. It's not a sustainable, globally competitive IT model. And that is just looking at IT. But IT is a real prototypical case of a lot of these alternative education use cases. Anyway, I digress. So either there's like a negligible nationalistic bias, or it's captured more effectively in something like the right-wing, left-wing questions, and so the marginal explanation is low. Or it could be that there is a nationalistic cross-correlation between something like the people who already think alternative education doesn't work, and the people who like want to hire out of country, so that the effect is there, but it's not in the direction of VOIQ1, which is qualifying for an entry-level position. There might be like a nationalistic bias, but not in the direction of that question. So in other words, like even if nationalism exists, it might have no bearing on the viability of alternative credentials. So ideally, there's just no nationalistic bias, right? But if there is a nationalistic bias, at least it doesn't have a bearing on this question, which is still moderately positive. Five, 6, 5, 9, 6, 1. Looks to me like 610 is the big loser, AQ9. Okay. AQ9, you lose, dog. You lose, dog. 0.57, 0.578. Oh, we actually have a tie. 0.578. 0.5. Oh, thank you for not having a tie. Handling ties is kind of tricky, right? So sometimes I'll drop both. And sometimes I'll drop one and the other and analyze them separately. But it's a lot easier if there's just not a tie. AQ2 squared is 0.639. AQ2 squared. Okay. Five, 7, 4, 5. So 574 is the loser here. Industry 3. So 5-1, 5-2. 5-2 is the loser here. And you're really starting to see some significant factors really emerge that are under these 0.0. It's like 0.0 something. It's like, okay, that's going to be one of the winners. Like apparently if you're a dude is really important. Gender doesn't exist. Fuck off. 0.51, 0.52. Like I've never seen a real sociological survey where gender was insignificant. So I don't know how you can say gender doesn't. According to science, it exists, dude. 5-2, 5-2. Is employee? Huh. It's saying it doesn't really matter if you're an employee. 9. Doesn't really matter. It doesn't really matter if you're an employee. Okay. So is manager is surviving. Ooh, is manager has a negative effect. Last time it had a positive effect. I think in the simple correlation it has a positive effect. So it must be that there's something else being held constant. This is why complex analysis is important. Ooh, I don't see any 5s. Do you see any 5s? 5, 5, 5. Booyah. So we have nothing over 0.5, which means that we have achieved a weak model. In theory, it's possible for the weak model to be identical to the max AR model and even the strong model, but it's rarely the case, so that's why we distinguish them. In theory, it could also be the long model. If everything in your long model is already under 0.5 and it maximizes AR and then eliminating, and then they're already actually under 0.1. Okay, so this is our weak model. Let's do our little trick over here. Reg VOI, so these guys get deleted. So we have 39 variables. Okay. So from F of 73 down to F of 39. So significant reduction in the number of factors. Was there a significant reduction in explanatory power? I don't think so. It went down 0.01. So now R squared is 0.52. So you see that gain on return on investment from a research standpoint. Now if you're an employer, and then the adjusted R squared is 0.4. So now if you're an employer, you would much rather use this weak model than that long model. And probably you're going to find that you'd rather use the max AR model as well, and you may even prefer the strong model. Depends how cheap you want to be, because from your standpoint, you can spend more on investigating your candidate, but that's an expenditure. So is that expenditure worth it in terms of the quality or risk reduction on candidate performance? Is that worth it to you? And the answer is like, sometimes I really don't need, that 5 or 10% gain in confidence is not worth like even asking even one more question. Sometimes employers really don't care. Other times employers really do care. It's like 5% return on investment. Come on, all I got to do is like ask a few questions and I can get like a 5% better candidate. Like definitely. So a lot of it comes down to employer attitudes. We're still looking at 188 observations, which probably indicates that the Q complexity is the same. So this is an interesting thing. It's like people who answered the questions. Basically, there's the new survey and the old survey. In the new survey, I added some questions. So I don't know if the sample is 188 from the new survey. But that way you can get that variation between the new questions. If I dropped a whole question, there might be some people who skipped or disqualified from that question, and your sample would go up. But as long as I'm holding that question, if I'm just reducing the number of answers, you may or may not see that in change. So for example, here I still have some industries. We dropped a lot of industries, but we didn't drop all of them. If I dropped all of them, then people who didn't even answer that question would come into the sample. Same with region. There are people who I don't know what region they're from. Like Mechanical Turk, it didn't tell me their region, not in the same way that SurveyMonkey told me their region. So Mechanical Turk said that they're from the US. SurveyMonkey had it broken down by like Northeast, South, Southwest, whatever like that. So actually, I think the entire Mechanical Turk, population did not answer the region questions. Just some notes on the sample. Time has no clear effect was a big deal. Felt like we uncovered some other cool stuff too, but VLIQ1 max AR. All right, so now what we keep doing is we keep dropping them until AR actually starts decreasing, which means that the benefits we're getting from consolidating factors are negatively outweighed by the loss in explanatory power we're experiencing due to factor reduction. And when it starts to swing that way, it's like, all right, you cut too many factors at that point. Like, stop. We're losing our value at that point. Again, that's unweighted for the cost of information collection. So you might find, no, keep cutting because it's still expensive to fill out that survey. All right, so the highest, answer me up, let's see. Dude, they have coffee here. It's amazeballs. Love that girl. I said, bring me some. So it's monotonous, right? But it's like this is how we do. We just pick the highest and just kill it. So 497 is my winner right now. 497. So AQ9 squared. So AQ9 squared, we don't care about. All right, so 486, 444, 4486. So industry 7. Goodbye. All right, so 459. Nickelodeon. All right, 459 is region 4. Okay. All right. Oh, this is my max AR going. So 4018. So 4 to 4018. So we're still going up. We're still in an upward direction. So 417. 417 AQ7 cubed. AQ7. AQ7 cubed. 4032 still upward. 421 is manager, doesn't even matter. Ooh, we're getting controversial over here, and you can see where there's this logical versus statistical conflict at a certain point. It's like, logically, I know it matters if you're either an unemployed person or a manager or a regular employee. You're going to have a different perspective, or maybe not. Maybe you're not. Maybe the research is telling us, like, dude, like, no, like, they all have the same, despite my personal anecdotal experience, whatever, or there is an effect, but it's either a low sample or it's like weak enough that even though it's there, like, it doesn't really matter in the grand scheme, bro. Like, maybe this is what the datas are telling us. But there's a certain kind of fairness where you can say, hey, I know it's a weak effect, but I feel like it matters. It's the one that I care about as a researcher, so I'm going to maintain this factor in my model. What's controversial, though, is just maintaining that factor at that p-value and cutting all the other ones around it. You would want to keep your whole model at an even p-value level. So that's why I like to have this weak model. It's like I can say, okay, it matters in the weak model. So maybe we need more samples, maybe something like that. But that's why I'm going to actually prefer the weak model over the max AR, because I know this factor matters and it's only surviving into the weak model. So basically, why would I go for max AR? If it's cutting one that I know matters, it might be cutting others that may matter. So maybe those other factors that are getting cut, maybe they matter just as much as whether or not you're a manager. Maybe the AQ9 effect we just cut matters as much as whether you're a manager. So 421, 428. All right, managers barely. Oh no, 472. Managers are surviving for now. Let's see if they make it. AQ8, AQ8. AQ8 cubed. It's AQ8 cubed is going to get next. Boom. Ooh, now managers matter even less. AQ8. Oh, but it's still going to survive. AQ8 is going down the tubes hard. We got 6-1. So the linear effect dropped the linear. Now we got 0.8. Right, AQ8 squared, AQ8 squared, drop it. So we're 4115. So we're still in an upward direction on the adjusted R squared. So let's keep cutting. Managers are not going to make it after all. They came so close, didn't they? 4-6. Managers came so close to mattering. But look, you can see the 95% confidence interval. It could be positive or negative. So that's the trick. Actually, when we took the sample back in February, I think there was a positive effect with being a manager. And I think I remember it being a weak positive effect. So now it's saying, hey, given your additional samples, like it's not clear it's a positive effect or negative effect. It could just be zero effect. Zero is within your confidence interval, so you got to cut it. At the end, like I said, with more research and more samples, at the end of the day, it could end up being positive. It could end up being like, 0.2, 0.25, 0.3, something like that. So we're going to keep sampling. We're going to resample. This October survey that I've done, we're going to try and grow that panel to at least be like 4, maybe 5 big survey blasts. And once we correct for like time, and then we actually get significant time and nonlinear time, really take out some of that noise and improve that explanatory power, just have more samples, and some of these results may change significantly. But as of today, doesn't matter if you're a manager. Today in America, we are all just humans. We're not employees and employers. Cherish this moment. All right, cherish. All right, so 413 still in an upward direction. Looking in my fours, there's a 449, 449 AQ 7 squared dropping. Affirmative. Now I hit a period. Whoops, for that period. 4148 still upward, I believe. So 4132 to 4148, 4132 to 4148 still upward. No fours cited. No fours cited. And so now we're probably going to see that adjusted R-square go down, I believe, because I believe when you start cutting factors that have a p-value less than your adjusted R-squared, I'm not sure this is like a statistical, mathematical truism or not, but just as a rule of thumb I've noticed, and maybe it is a mathematical truism, maybe it could be proven. When you start cutting factors that have a p-value less than your adjusted R-squared, it starts to tip in the other direction. Let's see if this might be our max, but let's see. So 4148, so here's 319 is our winner. 319 is the winner. So region 5. So cutting region 5. Going 41482, 4148. Ah, it didn't change at all, which might be to say it decreased but after rounding, it didn't appear to change. So that might be a technicality. But let's keep cutting. We didn't increase. So we're definitely getting near the tipping point if we haven't crossed it already. I think we already crossed it. I think it was just negligible. So 349, so 359, 349, 359, 359 is the winner, AQ3. AQ3 goes down the tubes. Boom. 4154, 4148. Oh, you know what? I have to withdraw my mathematical theory. 4154. It went up. Okay, and now we got this 0.8 AQ3 cubed. Okay, cut that guy. 4188. Now we're really getting a little bump here. 348, 348, AQ5 squared, AQ5 squared. .361 cage. 373 cage cubed. Cage cubed. And we're definitely at this point cutting factors that we know have a real effect at this point. So first of all, our R squared is starting to go down noticeably at this point. 4192. But our adjusted R squared is going up. But secondarily, like there's literature, like we know age has a cubic effect. We know age has a linear, marginal, and cubic effect. They're all important. But for statistical reasons, for reasons of statistical significance, they're being cut from this model. So when we have this like logical versus statistical conflict, we know we are choosing a simpler model for the purposes of having a simpler model, like a tool that we can use that is maybe easier for application. We know that this is not logically perfect. So we know that we're cutting real effects at this point, okay? So there are real effects that we're definitely cutting at this point. We're cutting them because either given our sample or given our question, they're either not super significant or not super important compared to the surviving other factors, which will be in our strong model. Or even in our max AR model. So this is why a weak model is really important, because you know that there are factors that matter that you're cutting. And there's just like this, as me as a scholar, it's like, I know this matters and I'm cutting it out. I almost feel dishonest in a way. But what I can do is I can include that weak model and I can feel honest again. I can say, it's a weak effect. So we know that effect is there. We have it. It's in our model. It's a weak effect. This is our preferred model, not because it has all the factors that matter, but because it's our bang for our buck sort of model. But if you want to go like more explanatory power than this bang for the buck model, here's some other factors like age. Like we cut age because it was getting statistically insignificant. But we know that it has explanatory power because watch when I cut it. Even though the p is 0.81, I'm going to cut it, and we're going to see the r squared go down. Right? 4975 to 4973. 4975 to 4973. It went down. So we know age matters. But my adjusted r squared went up. So we're gaining factorial efficiency. We're not gaining raw explanatory power. And so if you as a business person, you're like, hey, I want the most accurate model possible. I don't care about factorial efficiency. I care about explanatory power. Then you might want to go beyond the max AR model to even a weak model, possibly even past a weak model. Or you might try coming up with altogether new questions that weren't included in the sample. Another good way to go. So 4973, 4233. I don't see any threes, so 2-8 is our winner. So region 9, so cutting region 9. 4233, 4228. So we went down. All right, so we need to go back a step and include region 9, which we just cut, and this is our max AR model. So 4942. And you can see our adjusted r squared came up 0.02, but our r squared went down 0.03. So we actually, depending how you want to talk about this, we actually could have arguably lost more explanatory power than we gained in efficiency. But anyway, that's why when some statistician comes up and says, I think adjusted r squared ought to be our standard, there are good reasons for arguing with that. It's not always a winner. It's a great go-to, and it's a great point of reference that we understand what it means and we can talk. But there are very good business reasons where you might say, hey, dude, 0.03 on that r squared is going to be make or break for my profit margin. I need to be able to predict. I need a model that's going to outpredict the competition. It's not like profit moves linearly with accuracy. If I can gain 3% accuracy, just to use a completely different thing like hunting rifles or like military equipment or something like that. If I'm 3% more accurate, I don't get a little bit more profit. I get like all the profit. Like everyone buys my shit because I'm like 3% more. You see what I mean? If my nuclear reactor explodes like 3% less of the time, it's not like. So you need to weigh these things by their cost implications. On the other hand, if it's like, dude, 3% accuracy, we're in something where that totally doesn't matter, like fishing, and you like throw it 3% closer to the fish or something like that. Like, who gives a shit? I don't know. I'm making shit up at this point. The point is that r squared explanatory power difference needs to be weighed for its economic importance to establish which model is preferred. All right, so I want to count the number of factors. All right, so we got 26 factors, and then remove keyword reg, remove VOI. We got 24. Factors, still sample of 188. But now we're getting into something in the realm of something that's relatively easy to apply as a matter of business. Like a 24-question questionnaire isn't going to kill you, right? So let's go for the strong model. Get rid of this note. I'm just going to do that analysis separate. So after this factor analysis is done, I'll go back through and like go, okay, here are my surviving factors like Q3. Like, what is that question again? Why does that matter logically? And think through it from that perspective. But for now, I'm just doing this like, I'm not even recollecting what is Q. And it's like very much about mathematical analysis of the factors right now. Not doing too much analytically right now. From the analytically in terms of economic analysis, statistical and economics. Not really doing them simultaneously. It's easier to do them simultaneously when you have like very intuitive variable names. Like instead of industry 8, if it was like North Dakota, and then I could like kind of like simultaneously think through that. But there's a way in which you almost don't want to do that, and you want to keep the tasks separated. So we got the max AR, and now we're going to go for strong. All right, so let's cut it until we're all under 0.01. Or I'm sorry, 0.1. So we need to get rid of this 0.23. First, this 2.8. Okay, we'll get rid of the 2.8. The 2.8 is region 9. So cutting region 9. Okay. 263. 263 is region 1, cutting region 1. 2.8. Industry 9, cutting industry 9. And so strong model becomes useful for talking because it's like, you don't have all the factors that matter, but you have the most important factors. So it's like, I can say something like, dude, maybe it narrows it down so that industry effects are altogether eliminated. It's like industry effects did not survive to the long model. That's a concise, meaningful way to say something that matters. Or the only industry that survived to the strong model was transportation. It's like, that's interesting. Like, why? So it's really great for the strong model is useful for talking about. I don't mean to dismiss using a strong model. As much as I think that the 0.1 alpha level is arbitrary, or 0.05, as much as I think that those are arbitrary, I do recognize it's useful to have like a strong model and say, hey, these are the best factors. You're not maximizing your adjusted R squared, but you're getting like a huge amount of it for very few factors. Kind of like that 80-20 rule. And then I would say something like, if you want to do, I've talked about ordinal analysis before, so that 0.5 is like, it's a logical analysis, it's a logical delineation. It is more likely that there's an effect than that there's not an effect, so that's why you can have the line there. And then you can do levels of that, right? So you could say, I am confident that there's an effect. Why confident? Like, what do you mean by confident? Like, what number is associated with that? We'll just make it twice as confident. So that operation where you say from 0 to 100, cut it in half and say 50, make it 0 to 25. And then cut that in half and say 0 to 12.5. So I would be much more comfortable, and I would say that there's a lot more logic to using that 0.125 P threshold, alpha level of 0.125 or 12.5%, instead of 0.1. And then instead of 0.5, do 0.0625. So just cutting it in half again. And so what that would mean, and you can look on my website, afterecon.com, I've talked about ordinal analysis, ordinal logic, and this would be using that framework. So 0.5, 0.25 would be confident, 0.125 would be like very confident, 0.0625 would be something like very, very confident, but with a logical meaning to those terms, not just like you're some politician, like, I'm very, very confident we're going to win the war in Iraq. And like, what the fuck are you talking about? But actually having a logical framework to, well, what do we mean by very confident? Rigorously, what do we mean? Like as an academic, is that just a useless, is a lot of people take the approach that the word very is just useless. Well, no, it indicates something. Something which we're very sure about is that which we are more sure about than something which we are just sure about. How much more? There are mathematical reasons that just twice as much sure, or more than that, is an optimum, and it's just a logic of risk minimization. If I know that, anyway, you can go look on the website for more detail behind that. But if I know that something happens between 0 and 1 times, risk minimizing choice is 0.5. If I know it's between 0 and 0.5, risk minimizing choice is 0.25. And so on. So I would prefer a conversation where a strong model is talking about a p-value of like less than or equal to 0.125 or 0.0 or 0.125 or 0.0625. But 0.1 is like not super far off from that, so I'm not gonna like make a big deal about it. And I recognize it's a useful conversation. 235 is our current winner, so cut that. Or loser, I guess it is, 0.189. C provider 3. So C provider 1, 2, and 3. Here's an interesting note. C provider was the longest lasting cubic effect. Or no, the longest lasting full chain, linear, marginal, and cubic. So that's something that goes to speak to how powerful the C provider variable is. And that's, again, referring to, have you heard of, like, you'd ask, have you heard of the actual providers? Yeah, so 1, 2, 3, it's the only one. All right, so I cut the cubic finally. Just the notes, just interesting talking points that you're going to bring up in a paper or an article if you send the article to like a website, Popular Science or The Economist or something. Industry 8, cutting that. Okay, Industry 12.1. AQ7 actually gets cut. AQ7. Okay. 159. Industry 12. Right, so now industries have been cut completely. There's no industry effects survived. Region 16164. So these are some talking points, right? Region 7. Regions did not survive. 119, 115. 119, herd of Udacity, cut. Boom. Linda. Okay. Oh no, even Linda's going to get cut. Okay. 159, 129, 159. So here, having heard of specific providers is cut on the strong model. So think about how illogical that is. Are you favorable about alternative credentials has nothing to do with whether or not you've actually heard of alternative credentials. Well, of course it does. So that's why these strong models are just logically absurd in some cases. But this also highlights something important, which is comparatively, the number of providers you've heard of is much more important than which provider specifically. So being familiar with some providers or providers in general is much more important than being familiar with that provider. So it's not like Udacity alone has this overwhelming effect, or Coursera alone has this overwhelming effect. It's are people familiar with these platforms in general? And what we actually see is we see very strong negative linear effect with a positive marginal effect. How trippy is that? So that is some real analysis. That's some academic level analysis right there. AQ5 cubed is getting cut. AQ5 cubed is cut. And this is our strong model. Zeros all the way down. So we have a negative linear effect and a positive marginal effect. That means if you've just heard of like one or two online platforms, you're probably going to be pessimistic. But if you've heard of a bunch of them, you're going to quickly become very optimistic. Now, I'm very confident that there is an attenuating cubic effect, and that it's just maybe just a weak effect or a low sample, because you can't go to infinity. You can think of that mathematical curve in your head, a negative linear and a positive quadratic. It eventually go to infinity. There needs to be an attenuating cubic effect, or otherwise people would be infinitely favorable. You might want to argue that infinite favorability is plausible, but it's not really plausible given our operationalization of VOIQ1. It should max out at 10. Like, that should be the most that you can do. But anyway, I'll wrestle with that later. So here is, so 24 for the max AR model, and then 12, that's the 14 less the 2. So 12 for the strong model. And you can see how we've really narrowed it down to like a few factors that really matter. And the observation is 189. So what this appears to me is that it appears to be saying the new survey format was robustly important, because it appears like we're like dropping a lot of observations from the previous iteration of the survey, where they answered like fewer questions, like whole questions were missing. And so those in, I think, are getting dropped. And the fact that those in are getting dropped through the strong model means that some of these questions matter through the strong model. And you can see like AQ9. So I think like 7, 8, and 9 were the 3 that were added in the new survey, that those 1 to 10s were added. So 9, that's worth noting. So 9, regional and industry effects filtered. That's like they died, they didn't survive. That's another important note. Another important note is AQ9 survived to strong model. I think 7, 8, 9 were new survey questions. This explains sustained low N. Seems like throwing out old samples. And then one thing that I'll do is sometimes kind of indent like that to show that I'm continuing from the previous line. Just hit tab twice. All right, so and then so we got the N, R squared, adjusted R squared. The R squared is down to 0.43. So you can see the difference between the long model and the weak model. You cut a ton of factors and you don't really cut explanatory power. So from a return on investment standpoint, like let's use the smaller survey, because you're a lot of like SurveyMonkey, a lot of these tools you're paying per question can be really expensive. Think about if you're doing an email blast to your users. It can be vastly expensive, even if it's not expensive in terms of per question cost. You're going to have like drop-off effects, and there are other costs that you're reducing your completion rate, you're reducing your opening rate, you're pissing off your customers, you're taking more time, it's harder to analyze. So simplicity is valuable, right? But then the difference between an R squared of 0.52 and an R squared of 0.43 is arguably huge, because depending on how you cut up the numbers, like that could be more than a 20% difference. Because think about this. If I am 0.43, how much do I have to increase to get to 0.53? I have to increase like more than 20%. So that could look like I'm, again, depending how you cut up the numbers, it could look like I'm gaining 20% explanatory power in my model, or I'm gaining 20% accuracy. Take that in an applied scenario. If my customers, just a really extreme example, if my customers are purchasing 20% more of the time, right? Like they're abandoning their cart and checkout 20% less often, then is it worth it going from a 12-question survey to a 39-question survey? And the answer, again, is maybe. It's still not obvious, because 12-question to 39-question survey that I'm blasting out to my users in like my customer experience platform, like if I have a CX platform or research, market research, whatever I'm doing, the difference between a 12-question survey and a 39-question survey could be thousands of dollars, depending how this survey is carried out. Are those thousands of dollars outweighing the amount of revenue that you gain with the 20% reduction in abandoning? And it's like, well, it depends on like your product price and average cart size and stuff like that. But bottom line is, some situations you're going to want to prefer a strong model. Some situations you're going to want to prefer a weak model. So and the go-to is usually this max AR, which is like, forget about the cost of research and collection, just factorial efficiency, regardless of the price. That's why it's kind of like a nice go-to, because it's like I don't have to worry about that. Like I can think about that later, just kind of like on a purely mathematical level. This maximum adjusted R squared is pretty cool. So we got 0.43 and we got 0.40. That's actually not a lot of adjusted R squared loss. 0.43, 0.40. So I have half as many factors, and my adjusted R squared only went down by 0.02. So that's arguably pretty damn good. This might be a case where a strong model is pretty efficient, factorially efficient. And then I can actually get the Q complexity from here because it's pretty quick. So is male, that's your gender. I need to ask you Q2. I need to ask you Q3. I need to ask you Q4. But when I ask you Q4, I get all these. I need to ask you, so is male, Q2, Q3, Q4, Q9. Age is 6, income is 7. And provider, I knocked those all out in one question, have you heard of? So that's 8. So Q complexity is 8. Just to give you, just so you can see how that Q complexity is calculated. So if I'm asking you a survey and I blast that out, some surveys you'll have to pay by email recipient. Some surveys it's a cost per click, or cost per open, so only if they click or open it. Cost per response, only if they fill it out. You may have to pay for the completed response, or you may even have to pay for partial responses. You may have to pay per question. You may have to pay per answer, like per factor, like having more answers on the same question is more expensive. So a lot of those questions go into, and then is someone else handling the analysis, drawing up charts and stuff like that, or is it just kind of like SurveyMonkey, it's handling the questions only, and I'm going to do my own analysis? Or are you actually paying a statistical analyst who's going to be like, hey, business, here's some nice charts. Let me give you a presentation. I'll wear a suit. I'll come to your office. I'll have people with like master's degrees and will look really cool because you don't know how to do statistics. So you're an executive paying us, a statistical firm, to look extra cool and basically do the statistical analysis for you. So there are a range of research products, right? From like really bare bones to like really elaborate. Like maybe you're doing the whole consultants coming to your office I just described. or maybe you're not even doing survey software. Maybe you're just doing an email blast, right? Like a constant contact email blast, and constant contact doesn't even know that you're doing a survey. It just cares about the superficial emails. Or maybe you're just doing a Facebook ad, and Facebook doesn't know that on the other side of that click there's a survey. Facebook doesn't care. He's just charging you to click on the Facebook link. I feel like I'm rambling, but all those go into like affecting which model you'll prefer. I do want to wrap up by just remembering what is Q9. All right, 1, 2, 3, 4, 5, 6. Skip all these. 7, 8, 9. Look at that. So it looked like 7 and 8, whether you're religious or specifically Christian, those did not survive. But 9, government regulation helps ensure businesses treat individuals more fairly. 9 survived. With a tiny positive effect. So that's interesting, right? So we'll have to think about that. But it almost seems like people who are pro-regulation are also pro-alternative education, holding everything else constant. I think I did run into this in my simple analysis as well. Counterintuitively, conservatives seem more opposed to alternative credentials, and one of my hypotheses maybe it was an attitudinal opposition, that conservatives are more pro-free market, but this is outpaced by progressives pro-innovation. So it's pretty well known that like those on the political left are also, from a personality perspective, like Big Five personality, they're high in openness and like willingness to try new things. So that may in fact outpace their desire for regulation, and they may find themselves open to alternative modes of education, which would be really, really dope. And that'd be something great for this research to uncover, because I think traditionally political movements have targeted the right for like, hey, like let's do charter schools, let's do homeschooling, let's do private schooling. And they've really targeted the right, like you can do vocational education, you don't need to do four-year university. So they've really targeted the right for this social movement, but maybe what this research is telling us is like, hey, the left is where you're going to get this social movement. They're more open to it. They're more positive. So maybe we need to retarget that messaging toward those on the political left or on the social left and economically fiscal left. So that's a counterintuitive result, but it would be an important result. All right, thanks for watching how I do statistical analysis in STATA.